I'm sharing my screen. Okay. Okay. Today we'll discuss, means I will tell you the concept of this SR latch, and also we'll see the Verilog code, that is RTL code, and as well as the Testbench. I will explain you the data flow modeling as well as behavioral modeling. Okay. So basically the concept behind this developing this memory element is, suppose if you consider, one second. So if you consider like two inverters are connected back to back, okay, if you want to connect two inverters connected back to back, okay, so how you will connect, suppose if you say, so here, like one second. Okay. So suppose two inverters are connected back to back. So that means here, this is you are connecting like this. Okay. So here you are giving 0 means you are getting 1. Okay, you are getting 1, and you are giving 1 means you are getting 0. Okay. So this is nothing but it is acting as what, it is acting like a buffer, no? So whatever the input you are giving, you are getting the output. Okay, it is acting like a buffer. Okay, so it is acting like a buffer. So that means whatever the input you are giving, you are getting the output. Okay, A means what, the output is A only. Okay, so suppose if so the same inverters, two inverters connected like this, and you given the cascade. Okay, you given like this cascade. Okay, so cascade, and so how you are getting, suppose if you want to store 0 value, so here you are getting 0, you are getting 1, and here you are getting 0. So that I can store the value 0. Okay, if I want to store suppose if I want to store 1, here you are getting what, you are getting 0. Okay, and again you are getting 1, so that I can store either 0 or 1. It is acting as which element, memory element. Okay, it is acting as a memory element. Okay, so from this, so what I can say means, here I am taking this output, I am giving this as a qn, and I am taking this output, I am giving this is qn bar. Okay, I'm giving as a qn bar. Okay, so that means, so from this I can say that, so suppose if it is present state, okay, present state is, let us take qn equal to 0. The next state value is qn plus 1. Okay, qn plus 1, that is equal to what, qn plus 1 is 0. Okay, and qn is 1, and qn plus 1 is what, qn plus 1 is 1 you are getting. Okay, so here, this is nothing but we can call as a memory element. So we can store either 0 or 1. This is nothing but what, memory element. Okay, so here, we are realized the NOR gate and NOR gate, no, suppose NOR gate, first NOR gate I will tell you. Okay, so NOR gate, there are two representations are there. When I explain the NOR gate, how you realize the inverter by using NOR gate, one representation is this inverter, both inputs connected, tied together, you are getting what, a. So this is nothing but a or a whole bar. So here you are getting a bar. Okay, here you are getting a bar. Okay, second representation is, this you can connect like this also, you can connect like this also. Okay, so this is what, this is connected to 0, and this is connected to a. So you are getting what, a or 0 whole bar, this is equal to what, a bar. Okay, so this representation I am going to replace in this diagram. Okay, this second representation I am going to replace this in this diagram. Okay, so if you replace, so what happens, I will get like this. So that means, this is one NOR gate. Okay, and this is one more NOR gate. Okay, inverter, and this is connected with ground, and this is also connected with ground. Okay, and output will be feedback like this. Output will be feedback like this. Okay, so that means, here, so we have no control over this input. Suppose here if you are giving like a 0, this is nothing but latch only. Okay, latch, here you are getting 1, again here you are getting 0, so I can store the value 0. Okay, like that I can store the value. Okay, so that means, if I connect these grounds, means in a common phase, okay, that is linear phase diagram, you will get what, SR latch. Okay, so that is RS latch using, so RS latch you'll get this diagram. Okay, this diagram is there, no? So this diagram how I am connecting means, so that is what RS latch. This is we can call as a linear phase diagram. Okay, so this is nothing but linear phase diagram. Okay, so how I am connecting means, one second, yes, okay, so linear phase diagram. So here this is NOR gate, and this is one more NOR gate, and these two are connected like this, back to back. These two are connected back to back, and this one I am giving as R, and this one I am giving as S, and this is so present state is what, Qn, and present, this is Qn bar, and next state is Qn plus 1, and this is present state. Okay, present state and next state. Okay, so present state and next state. Okay, so if you see, yeah, so this is next state. Okay, this is the complement of this Qn plus 1 bar. Okay, so this diagram we call as linear phase diagram. Okay, linear phase diagram. So this is the basic thing for sequential circuits. If you understand this SR latch by using NOR gate and NAND gate, you can understand the flip-flops also. Okay, so I'm starting with this latches, and I'm trying to write the program for this SR latches also. I will show you the simulation part also. Okay, so simulation how we are doing. Okay, so suppose like SR, so this is RS latch using NOR gate, no? So this is what RS latch using NOR gate. Okay, using NOR gate. So here this is the diagram. First what I am doing, I am drawing this like this. Okay, so this is like this I am drawing. So this will be feedback, and this will be feedback, and here this is R, and this is S. Okay, and Qn and Qn bar. Okay, this is the present state, and what is the next state? Next state is Qn plus 1, and this is Qn plus 1 bar. Okay, so next you need to draw the characteristic table. Okay, characteristic table. So what is the characteristic table? Suppose the inputs S, R, and Qn. Okay, these are the inputs and present state. Okay, this is the present state, and the next state, what is the next state? Next state is Qn plus 1. Okay, so 3 inputs are there. How many possible combinations? 8 possible combination, no? 0 0 0 0 0 1. Okay, and next 0 1 0 0 1 1, and next 1 0 0 1 0 1, and 1 1 0 1 1 1. Okay, so here if you see, so I can get the expression also. Suppose what is Qn plus 1? Qn plus 1 equal to, so this will be feedback, no? So this will be feedback means, so this is NOR gate. I can write as what, R plus Qn bar whole bar also I can write. Okay, Qn bar whole bar. Okay, and Qn plus 1 bar equal to what? Qn plus 1 bar equal to what is this? S plus, okay, S plus Qn whole bar. Okay, Qn whole bar. Okay, so from this expression also you will get that one, but I will take the cases. Okay, so without this I will take the cases, and I will try to get the this characteristic equation. Okay, so here if you take like this, let us take one first case. What is the first case? First case is, let us take what Qn equal to Qn equal to 0. So Qn plus 1 equal to what? 1. Okay, so that means this will be feedback. So this will be feedback. First you will write the truth table for NOR gate. Okay, A, B. Okay, what is the truth table for NOR gate? So Y. This is just opposite of NOR gate. 1 0 1 1 means if any one of the input is 1, the output is G. So OR gate means 1, no? So here you will get 0. Here you will get 1. Okay, this is the NOR gate truth table. Okay, so from here, so that means this will be feedback. So first R and S are 0 0. R and S are 0 0. So this will be feedback. So so 1 will be feedback. So what you are getting 0 and 1. So 0 and 1 means what? 0 only. 0 and 1 is 0 only. Okay. And this 0 will be feedback. 0 and 0 means what? 1 only. Okay. So that means in this when Qn is 0, what you are getting 0 only. Okay. And next state we'll see. Next state when Qn equal to 1. When Qn equal to 1, this becomes what? 0. Okay, this becomes 0. And so this will be feedback. So anyway R is 0 and this one is 0 only. Okay, 0 0 means what? You are getting 1. Okay, again this will be feedback. Anyway S is 0 and this is 1. Okay, 0 1 means what? 0 1 means you are getting 0. Okay, so that means when you are giving 1, you are getting 1 only. You are getting 1 only. So that means the next state value is the same as the present state. Okay, so that means this is nothing but we call as a memory state. Memory state. Okay, memory state. Okay, and next case we'll see. Okay, this is case 1. This is case 1. Okay, so if you consider case 2, okay, so this is case 1. This I already did. Okay, this is memory state. And one more time I am drawing. This is SR latch. Okay, SR latch by using this NOR gate. Okay, so NOR gate I am drawing. So here this will be feedback and this will be feedback. Okay, and R, yes, Qn and Qn bar. Okay, this is present state. And next state, what is the next state? Qn plus 1 and Qn plus 1 bar. Okay, Qn plus 1 bar. Okay, so what are the cases I am taking? So that is S equal to 0 and R equal to 1. So S equal to 0 and R equal to 1. What is the case? We'll see. First case we'll see. So Qn equal to what? Qn equal to 0 and Qn, so Qn equal to 0 means what? Qn bar becomes 1. Okay, so this will be feedback. So that means here this is 1. Both 1 1 means what? You are getting 0 only. Okay, and this 0 will be feedback. So 0 0. So 0 0 means what? You are getting 1. Okay, so this case you are getting which state? That means here you are getting 0. Okay, and next case I will check. Okay, what is the next case? R is 1 and S is 0. No, R is 1 and S is 0. Okay, so next case I am checking. That means Qn is 1 and Qn bar is what? 0. Okay, Qn bar is 0. So this will be feedback. So that means 0 will be feedback. So what you are getting? 1 and 0. So 1 and 0 means what? You are getting 0 only. This case also you are getting 0 only. And this will be feedback here. 0 and 0 means what? You are getting 1. Okay, you are getting so here also you are getting here you are getting 1. Okay, so this is what? This is 1. Okay, so that means both cases you are getting what? 0 only. Both cases you are taking Qn equal to 0, Qn 0 and 1. Both cases you are getting 0 only. Okay, so this case we can say that this is nothing but what? Reset state. Reset state. Okay, and next case 3 we'll see. Okay, case 2 is completed and case 3 I will draw and I will explain case 3. Okay, so case 3 just so here this is NOR gate, this is NOR gate. Okay, so if you understand this, you can analyze the SR latch by using NAND gate also. So the simple, like by using NAND gate, here you need to keep S and you need to keep R, and based on the truth table you need to analyze the truth this characteristic table. Okay, so here this is what? This is R and this is S and present state. Okay, this is Qn, and what is the next state? Next state is Qn plus 1. Okay, and the complement of this Qn bar and Qn plus 1 bar. Qn plus 1 bar. Okay, so what are the cases I need to take? Let us take the cases. See here, third case. Okay, so this is the third case. So R equal to what? R equal to 0. Okay, R equal to 0. Okay, one second, somebody here. Okay, yes, See here. So r equal to 0 and s equal to what? 1, no? So s equal to 1, okay? And the first case I am checking. That means qn equal to what? 0. This case I am checking. Qn equal to 0, qn bar equal to what? 1, okay? So this will be feedback. So that means 0 and 1, okay? 0 nor 1. 0 nor 1 equal to what? 0 nor 1 equal to, 1 second. 0 nor 1, 1 second. 1 second. I will check with this case. This is 0, no? So s equal to 0, s equal to 1 and r equal to 0. This will be feedback. So this will be feedback means this is what 0. This is what 0. Okay, 0 1. 0 1 means what? This is 0. Okay, this is 0 and this will be feedback. So this is 0 0. What you are getting? 1. What you are getting? 1. Okay, and next case I will check. Okay, what is the next case? So next case is, okay, next case is, yeah, 1 second, yes, next case, what is the next case? Yeah, tell me. See here. Okay, see here. So s equal to 1 and r equal to 0. S equal to 1 and r equal to, s equal to 1 and r equal to 0. Okay, next case is qn I am taking as 1 and qn bar I am taking as 0. Okay, so that means here 0 0. So 0 0 means what? 0 0 means you are getting 1. Okay, again this will be feedback. 1 1 means what? You are getting 0. Okay, so both cases you are getting 1 1 only. Okay, first case you are getting 1 and second case you are getting 1 only. Okay, so this case is nothing but set state. This case we call as set state. Okay, this is the case 4. Okay, and next case 5 I will check. Okay, case 5. Okay, sorry, case 4. Case 4. What is the case 4? I need to keep s equal to 1 and r equal to 1. Okay, so one more time I am drawing the diagram. SR latch by using NOR gate. Okay, SR latch by using the NOR gate. So this will be feedback and this will be feedback. Okay, so these are the gates only. Just there is a feedback network. This is acting as a memory element. Okay, so this is R and this is S. Qn bar Qn. This is Qn only. Present state Qn and what is the toggle state? Qn bar. Okay, this is the present state. And what is next state? Next state is Qn plus 1 and this is Qn plus 1 bar. Qn plus 1 bar. Okay, so what is the case I need to check? So r equal to 1 and s equal to 1. Okay, r equal to 1 and s equal to 1. Okay, so r equal to 1 and s equal to 1 means so I'm checking for first case. What is the first case? Qn is 0 and Qn bar is what? 1. Okay, so this will be feedback. Okay, so 1 1. So 1 1 means what is the output of our NOR gate? 1 1 means 0, no? So 1 1 means what? You are getting 0. Okay, and next this 0 will be feedback. 0 1. So 0 1 means what? You are getting 0 1 means what? 0 only. Okay, 0 1 means 0. Okay, this case you are getting. Okay, and next case I will check. So that means s is 1 and r is 1. Okay, qn equal to 1 and qn bar is what? 0. Okay, so 0 0 will be feedback. 1 0 means what? 1 0 means if you see the NOR gate, 1 0 means what? 0 only. Okay, so 1 0 means what? 0 you are getting, and this will be feedback. Okay, 0 0. So 0 0 means what? You are getting 0 only. Okay, so that means here that means for both cases qn, suppose qn plus 1 is 0, it should be toggle, it should be 1, but you are getting same value. So qn plus 1 here, you, 1 qn is 1 for this case, so you are getting qn plus 1 as 0, so it should be toggle, but you are getting what? Same 0 only you are getting. Okay, so practically it is not valid. That means that we can call as this is the indeterminate or invalid state. Okay, so basically in all the cases if you observe, you are getting qn plus 1 as 0, qn plus 1 bar as what? 1. Okay, if it is 1 you are getting 0. Okay, so memory state. And second case also you check. So 0 1 0 1. Okay, so both are complement here. So both are complement you got. Okay, here also you check. Okay, here also when you see this one. Okay, when you see this one, so what you got? So qn equal to qn plus 1 is 1, you are getting 0. Here 1, 0. Okay. So both are like, if it is true form, you should get complement form. But in fourth case, you are not getting like that. Okay. What you are getting, both values same. Okay. Both values you are getting same. Okay. This is nothing but we call as a invalid state or forbidden state. Okay. Invalid state or indeterminate state. Okay. So this case is nothing but what we can call as invalid state. Okay, this case is we call as invalid state. Invalid state. Okay, so invalid state. So here you got the characteristic equation. So the when s equal to 0 r equal to 0, which is state, memory state. Okay, when s equal to 0 r equal to 1, this is reset state, and s equal to 1 r equal to 0, this is set state. S equal to 1 r equal to 1, this is nothing but invalid state. Okay, so from this characteristic table I can draw the truth table. Okay, how to draw the truth table? So I am drawing the truth table. So here I am drawing the truth table. S, R, and qn plus 1 and state. Okay, so here you see. So here if you write, so two inputs are there. How many possible combinations? 0 0. Okay, here you can write 0 1, 1 0, and 1 1. Okay, so here when it is 0 0, what is that state? Memory state. Okay, memory state means what? We can write as what? Qn only, no? So whatever the value of this one, you are getting Qn. Okay, so this memory state I can write as what? Qn. Okay, reset state means I can combinedly I can write 0. Okay, in digital anything is 0 means reset state, and combinedly I can write this as 1. Okay, combinedly I can write as x. Okay, so that just writing this truth table by seeing this characteristic table. Okay, so this is what Qn, and this what is the state? Memory state. Okay, and here this is a reset state, and what is the, so what is the state? Reset state. 0 means what? Reset state. Okay, 1 means what? Set state. Okay, 1 means a set state. Okay, and 1 1 means what? Forbidden state. Okay, or invalid state. That is not possible. Okay, that is invalid state. Okay, hope you understood how I am developing the memory and how I am developing this SR latch, RS latch by using NOR gate. Okay, so like this you need to analyze. Okay, if you analyze, you can remember the concepts for more every means forever. Okay, so NAND gate is same only, just how you will get. So NAND gate you can try. So SR latch using NAND gate. Okay, NAND gate you can try. Okay, so just I will give you just idea how what you are getting this NAND gate. Okay, 1 second. Yeah, see here. So yeah, NAND gate means here what you are doing, just here this is NAND gate, and this is one more NAND gate. Okay, one more NAND gate. You can analyze. Okay, so this one is this one will feedback. Here you are taking what? S and R. Okay, S and R, and this is the present state Qn. And what is the toggle state? That means toggle is Qn bar. This is present state. What is the next state? Next state is Qn plus 1 and Qn plus 1 bar. Qn plus 1 bar. Okay, so this is SR latch by using NAND gate. And just you draw the truth table for NAND gate. So what is the truth table for NAND gate? So A, B, just complement of AND gate is nothing but NAND gate, no? So you draw this 0 0 0 1 1 0 1 1. Okay, so that means here just complement. So any one of the input is low, the output is high, and 1 1 means what? Both the inputs are high, the output is low. Okay, so like you write the truth table S R, and so 1 second. Yeah, S R, and present state Qn, and what is the next state? Qn plus 1. Okay, so if you analyze, so this is the present state and this is the next state. Okay, so what you will get means here, so what are the possible combinations? 0 0 0. So like this, whatever I told with NOR gate, no? So like that you analyze. Okay, based on this truth table, 4 cases you analyze. Okay, so 0 1 0 0 1 1, and next 1 0 0 101, okay, and next 110, 111, okay. So that means here you will get what, here invalid state you will get. This is what invalid state, okay. Invalid state you will get, just you analyze, okay. This is set state, okay, this is set state, and this is reset state, and this one is memory state. So whatever the qn value is there you are getting, okay. So this is memory state you will get. So you need to analyze 4 cases by using this, taking this inputs S and R, and you need to take these values, okay. 2 values you need to take, and you need to check what are the next state values you need to check, okay. Truth table also, from this characteristic table you will get the truth table, okay. So from this characteristic table, so S R qn plus 1 state, okay. So here so how many possible combinations? 0 0 0 1 1 0 1 1, okay. So here 0 0 means what? Seeing this you can write, okay. This is invalid state, okay. And next this is set state, and this is reset state, and this one is qn means what? Memory state, okay. This is nothing but memory state, okay. So like this you can draw the SR latch by using NAND gate, okay. Hope you understood. So this is the basic part, understanding of this latch is the basic part for understanding the flip-flop, okay. So if you understand this concept, so next class I am going to explain the flip-flops, okay. Two flip-flops, SR flip-flop and D flip-flop, that Verilog code also I will going to explain, okay. So for a flip-flop also you have like characteristic table, truth table, characteristic equation, and state diagram. All those things will be there, okay. Hope you understood this one, okay. This you try, okay. So this is your task, you can try with your own, so that try to understand the concepts. Next I am going to the programming, okay. So I wrote this programming by using 2 methods. One is data flow modeling and behavioral modeling, okay. So hope this is visible. I am using Xilinx Vivado, okay. So see here. So this one second, yeah, I'm zooming it. So module SR latch, so DFM is nothing but data flow modeling, okay. So input wire S, so whatever the inputs are there, I'm initializing with wire data type, okay. Input wire S, input wire R, and output wire Q, and output wire Q of naught, okay. So I'm using a continuous assignment statement, assign Q equal to naught of, based on my expression only, okay. So you got, so that means so naught of Q and one second. So this is what naught of R and Q of naught, no. So initially I told here so here you got the expression, no. One second, yeah, you got the expression using NAND gate, NOR gate. I wrote the expression, okay. Here I wrote the expression, qn plus 1 equal to R plus qn bar, okay. So here so that means based on the data flow modeling only I am writing. So qn plus 1 equal to what? R plus qn bar whole bar, okay. And qn plus 1 bar equal to what? Qn plus 1 bar equal to S plus qn whole bar, S plus qn whole bar, okay. So that I am going with, I am writing in terms of what? Expressions, okay. So this is what assign, I am using a continuous assignment statement, q equal to naught of R plus q of naught, qn, okay. Q of naught is qn whole bar, okay. I am using a bitwise operator, and next assign q of naught equal to naught of S or qn, okay. End module. So simple. This is I am using with the help of these expressions, okay. So this is nothing but data flow modeling, and I told you, no. So data flow modeling and behavioral modeling can be synthesizable, okay. We can convert into hardware, okay. And for this I wrote the test bench also. This one is the test bench, okay. So if you see the test bench, okay, so here module SR latch DFM underscore TB. So whatever the input variables are there, I need to initialize with reg data type, and whatever the output variable outputs are there, that I need to initialize with y data type. I need to instantiate. Okay, I need to call that design. Okay, so what is my design name? So that means a design name, instance name is what? SR underscore latch underscore DFM design and a test. Okay, so whatever the variables outside, those are nothing but design variables. Whatever the variables inside the bracket are nothing but test bench variables. Okay, and this is nothing but what? Instantiation. Okay, after that, so if you do with EDA playground, you need to initial begin. You need to use these two commands like $dump file sr latch dot vcd, $dump vars 0 comma sr latch tfm underscore tb. Okay, so you can use by using this EDA playground, so that you can see the waveforms also. Okay, and dollar monitor. Monitor is nothing but system task. If there any change in the inputs, this will be displayed. Okay, this will be displayed, and you need to initialize the reg variables. No, so there are the 4 steps are there. First is what? Declaration of these internal variables and instantiation, and after that you need to initialize the internal variables. Okay, so internal reg variables, what are the reg variables? S and R, these are the reg variables, and giving the stimulus. Okay, giving the test vectors. Okay, so here what I am doing for integer, I am initializing an integer, I am using for loop, I am checking for all the cases. What are those cases? 0 0 0 1 1 0 1 1. So I equal to 0, I less than 4, I equal to what? I plus 1. Okay, so in Verilog we need to give what? I equal to I plus 1. Okay, so if you are giving I plus means it will not take, you will get a syntax error. But in SV and all those C, C++, all those high level language, we can give I plus plus also, that compiler will take, but here compiler will not take. Okay, so if s equal to 2, I am using a ternary operator. Okay, if s equal to 2, what I should get? That I need to get 1. Okay, if it is 1 0, I should get s equal to what? Set state. If r equal to 1, r equal to 1 means what? 0 1, I need to get reset state. Okay, and if I equal to 3 means what? 1 1 means I need to get invalid state. Okay, so this I am writing for what? I am writing for I am writing for SR latch by using NOR gate only. Okay, I am writing and displaying these values for every 10 time minutes. I am displaying this. Okay, so this is the test bench. So I want to execute this. Okay, so if I want to execute this, I want to see the I want to, one second, BFM, this is okay, I want to see the circuit. One second. BHM will be executed. Okay, in the design, if I want to see the design, so what I need to do means I need to right click and make this as a top module. Okay, one second. What happened? One second. So this one DFM, no, DFM, right click, set as top. I need to make set as top. Okay, here also DFM, I want to see the simulation, right click, I need to make set as top. Okay, I need to make setup. Here 3 dots are coming means it is a top module. Okay, it is acting as a top. Okay, so here I want to elaborate the design. Okay, I want to see the hardware. Okay, so open elaborate design. Okay, if you open elaborate design, just observe what I am getting. See here, this is nothing but my hardware. Okay, NOR gate by using which latch? Means SR latch by using NOR gate. OR gate followed by inverter, no? OR gate followed by inverter, and Q is as acting as a feedback to this S RS latch. Whatever I explained. Okay, I explained here, no? So that means RS latch by using NOR gate is nothing but R I took first and S I took next, no? So when I'm writing the program, compiler also giving the same diagram. Okay, so this is the hardware, gate level netlist, or we can call as a schematic. Okay, and if I want to see the simulation, just I'm closing this. if I am closing this, run simulation. Okay, go to run behavioral simulation. Run behavioral simulation. Yeah. So I got the simulation. You can see the output in the TCL console also. Okay, see here for different values of S and R. So S equal to 0, R equal to 0, I am getting invalid state, and 0 1 0 state, S equal to 1 0 1 state, like that I am getting. And you can see the waveform also. See here, I am getting in the waveform. Just expand this and fit to page. Okay, so S equal to 0, R equal to 0, invalid state I am getting. And next S equal to 1 and R equal to 0. Okay, Q equal to 1 I am getting. And S equal to 1, S equal to 1 and R equal to 0. Okay, different cases I am checking the inputs. Okay, like that. Okay, S equal to 0, R equal to 1, Q equal to 0, S equal to 1, R equal to 0, Q equal to 1. Okay, and S equal to 1, R equal to 0, it will be in memory state, like that. Okay, I am getting this is data flow modeling. Okay, and next is behavioral modeling. So this is the behavioral modeling. So whatever the program you want to add, just go to the design source, add that and give the design file. Okay, next if you create the design file, this will be created in this. Okay, so like you can add so many designs also. Suppose if you are writing for flip-flops, you can write SR flip-flop, D flip-flop, JK flip-flop and T flip-flop in one design. Okay, you are creating one project file flip-flop. Okay, here I created the project file latch, so I am writing the SR latch by using DFM, and SR latch by using BHM. You can write JK latch also, D latch also. Okay, you can write D latch also. Okay, you try for D latch. Okay, you try to understand that. And here this one design set as top. Okay, I need to make set as top. And this is Testbench also. Okay, you set as top. Okay, make a set as top. Behavioral modeling. Okay, this is behavioral modeling. So what is behavioral modeling? You see this program. So module SR latch. Okay, so one second. Yeah, so this one module SR latch underscore BHM is nothing but behavioral modeling. Okay, input S, input R. So that means input S, input R means we are not defining any data type. By default it will take as wire data type. Okay, wire data type. And output, what output, we are using behavioral modeling, output should be reg data type. Okay, so that's why I given output as reg data type, output reg q. Okay, output q bar, output q bar. So this is wire data type. Why? Because this q bar I am using in the procedural continuous assignment statement. Okay, so what is this continuous assignment? I am using in the assign statement, no? So that's why this you need to initialize as a wire data type. Okay, assign q bar equal to what? Not of q. Okay, I need to assign q bar equal to not of q, always at the rate SRR. SRR means what? These are the sensitivity list. Okay, so in case of here I can keep star also, that is implication operator. Okay, I can keep star also. So if you are keeping a star means what? If there any change in the inputs, you'll get the change in the outputs. Okay, that is implication operator. I told you, no, like you have like 100 inputs are there. 100 inputs you can't write in this sensitivity list, no. So with the help of that means in the place of 100 inputs, we can keep star. Simply star means it will be applicable for all the inputs. Okay, so here only two inputs are there. I can give the sensitivity list as S and R. Okay, I am using case statement. Okay, so case S comma R. So this S comma R I'm writing in concatenation operator. Okay, so this flower bracket is nothing but concatenation operator. And I need to check for the switch level switches. So that means 2 tick binary 0 0 1. So this is nothing but SR latch by using NAND gate. Okay, q equal to what? 1 tick binary x. And 0 1 means what? Q equal to 1 set state. Okay, not reset state. So this is set state, and this is invalid state, and this is reset state, reset state. reset state, and this one is what no change or memory state, we can call as memory state. Okay, previous state. Okay, end case. Okay, I need to end the case, and I need to here always is started with the begin, no. So where I will write the begin, if you have the multiple statements, I need to write begin and end. Okay, so here multiple statements are there, that's why I wrote a begin and end module. Okay, so this is the simple code for SR latch by using NAND gate using the behavioral modeling. Okay, so if you see the test bench behavioral modeling. Okay, this is the test bench. Okay, so see this test bench. So I told you, test bench you have like 4 steps or 3 steps also it will be taken. Here you see, so see here whatever the input variables are there, so module tb sr underscore latch bhm, this is the test bench name, and whatever the input variables are there, I need to give it to the reg data type. Output variables are there, I need to give it to the byte data type. I need to instantiate what connection by name. Okay, so this is instance name sr underscore latch bhm, unit under test, UUT is nothing but unit under test. Whatever the variables outside this one are nothing but design. Okay, so test bench is nothing but for the design you are giving the inputs, design will process and it will give the outputs. Okay, so whatever the variables inside this bracket are nothing but test bench variables. Okay, I am initializing an integer data type, integer I, initial begin, dollar display sr q bar, and I am using for loop for I equal to 0, I is less than 4, I equal to I plus 1. So I need to check for all the cases, no, 0 0 0 1 1 0 1 1. Okay, so I am using concatenation operator s comma r equal to what, I of 1 is to 0. Okay, 2 bits, no, so 2 bits, s and r are 2 bits. Why? Because that's why 1 is to 0 I need to give. Okay, so that means if it is 0 means it will take 0 0, if it is 1 means it will take 0 1, and if it's 2 means it will take 1 0, and if it is 3 means 1 1. Okay, so 0 to 3 it will be executed. Okay, and I am giving a delay of you can give delay of 10 also. Okay, I can give delay of 10 also, and display these values. Okay, dollar percentage b percentage b percentage b percentage b s r q bar. Okay, and begin end, I need to end this. Okay, I need to end the simulation. I'm using a system task, that is dollar finish. Okay, and initial begin is there, no, so initial begin, so it will be executed only one time. I told you, no, initial will be executed only one time, and this is non-synthesizable, we can use for the simulation only. So that's why in the test bench we can use initial begin, but in the design we can't use initial begin. Okay, so in the test bench I can use initial begin, initial and begin and end, multiple statements are there, so it should start with the begin and end module. Okay, so this is the test bench. So here I want to see the design. Okay, so if I want to see the design, where I need to go, open elaborated design. Okay, save this file, yeah, you got this. So that means this is you are getting this is a D latch and 2 more muxes are connected like this. Okay, so that means compiler is making the RTL netlist like this. Okay, here this is Q and it is coming through the inverter, this is Q bar. Okay, so this is mux. Okay, R and S is connected like this as a selection line, and 2 inputs are there, 0 0 0 1 1 0 1 1 you are getting. Okay, so this is elaborated design. I want to see the simulation. Okay, so I want to see the simulation. So run the simulation, run behavioral simulation. We run the behavioral simulation. You can see in the TCL console also. Okay, that I dollar display given, no, here you got the truth table, see here. So S and R, 0 0 invalid state, 0 1 that is set state, 1 0 reset state, 1 1 memory state. 0 means what? Memory state, whatever the previous state is there, previous state is 0, no, so you are getting the memory state. Okay, so and next this is TCL console. and next you want to see the simulation. Okay, yes, see here. So same thing you will get that as a truth table fit to page. Okay, so if S and R are 0 0, okay, what state? Invalid state. This is invalid state. And 0 1, 0 1 equal to what? 1, you are getting 1. Okay, and next 1 0, 1 0 means what? 0 you are getting. Okay, 1 0 means 0 you are getting. And 1 1 means what? Previous state. What is the previous state? That means memory state. So memory state is what? 0, no? So that 0 you got it here. Okay, so you got 0. Okay, so that means I seen the functionality of my SR latch by using NAND gate by using the simulation. Okay, so verification, this is nothing but one type of test bench, is nothing but we are verifying that whether your design is correct or not. Okay, so by using Verilog up to FSM you can write the test bench, you can write the test bench, but if you are going for higher level like SOC or IP, IP and higher level IPs, you can't write with Verilog. You need to go for SV and UVM. Okay, that is design verification. Okay, yeah. Once again.